We've talked a lot about it. Now time to actually make some concrete. So, first of all, what is the most important material in concrete? Cement. So, in this container here, I have a mixture of blast slag and cement. I hope you can see that. And then, in order to react our blast slag and cement, I have a little cup of water. Then I have some sand. And I also have PVA fiber, which we'll be mixing into our concrete at the end. And then 2 admixtures. Now, I'll be using a egregious quantity of both of these, simply for better visuals. I think it's easier to see instead of me putting out a mil. I'm putting in nearly 10, just so you can more easily see this. And I think it's good to see like the volumes. Don't use this much, especially in this quantity of material. You simply will not need this much admixture. Important note. You may see that, or maybe you can't see, but I have about 8 ounces of water here, and I have about 1.8 pounds of 1.7 pounds of blast slag and cement in a ratio that I find fun to work with. Now, that is not normal. That is way less water than you would normally use, and that is compounded by the fact that the sand in this cylinder is dry. Whenever you're mixing your own concrete, you want to have saturated surface dry aggregate. What does that mean? Well, just like concrete, just like a sponge, most things in this world are porous. That includes sand and probably most of your lightweight aggregates, especially things like puff shale, which are very, very porous. Saturated surface dry means that while the surface of the material is dry, the inner pores of the stone is full of water. Now, saturated surface dry water does not actually contribute to your mixed water or your water cement ratio, at least for the most part. There's always exceptions, right? But it's important that you're in saturated surface dry, because if you're not, if your sand is completely oven dry, like this sand is, then once you combine all your ingredients in your mixer, you will find your mix is much drier than it should be, because your aggregate has sucked most of the water out of it. And depending on how much aggregate you're using, even if you're at 1% absorption, if you have 10 pounds of aggregate, you can see how you are actually absorbing quite a bit of water very fast, especially when you're working with low water cement ratios, which you probably should be if you're working with lightweight concrete, as low water cement ratio typically gives you much greater strengths. So, obviously I'm not going to mix right now because I'm not going to have my mask on, but I will mix everything off camera, and then we'll go look at how that looks. Now, before I do that, a few last things, some prep. Our air entrainment, this pink goo, we typically put directly in our water right before we start mixing. So, I'll just sort of stir that now. Squirt it in, and then you want to make sure it's really nice and spread out in there. You don't, want it like in a puddle. Of course, it's water; it'll spread out very well. But you just want to make a nice mixture. And I don't know if you can see that, but the water has gone from clear to a nice pink lemonade color. So, I'm going to put these together off camera, and I'm also going to put a mask on, but I figured no one can hear me when I'm muffled through a P100 filter. So I'll do that off camera. But the order I'll be adding these ingredients in is I'll be adding in our sand, and then our dry, the sand's dry, sorry. I'll be adding in our sand and our PLC and blast slag mixture. I will be letting it homogenize. Typically, we do this for several minutes, but as I'm not using this for anything structural, I'm probably just gonna let it mix for like a second or two. And then I will be adding in the water. The next video will pick up, or the next part of this video, will pick up after I've added the water, and we will get a really good idea of what effect high range has on a mix. Okay, so This is what it looks like after I've added the sand, the blast slag, and the cement, as well as the water with the high range, or sorry, not the high range, the air entrainment added into it. Now, you'll see it looks useless in there. You could not use this for anything. Maybe if you had a crew of guys with some tamping rods, you could make a nice foundation, but even that would be a stretch. So, I will be taking some high range. It's a Sitka 2100. It's the high range I like to use because we have a 5-gallon bucket of it, so I don't have to ever buy any more. Now, because our water cement ratio is so low, and also because I will not be using this for anything, I'm going to put a lot of high range in here. So I'll do that now. Okay, the bottle's not primed. And we'll start mixing. So already, I think you can probably get a pretty good view of why a gravity mixer is not the best for concretes with a very low slump or with a very low density. Because it's a gravity mixer, because it relies on dropping concrete onto itself, if it is very light or very stiff, it will not mix properly. That being said, we can already see the high range really getting to work, and I'm gonna give this just one more squirt because I'm impatient, and then we're gonna keep mixing. So you can see pretty well how runny this concrete is. You would not really want concrete like this for anything, right? It's simply too much liquid in there. You're not gonna be able to set in a form without it really just running through any crack or crevice. So this would be useless. However, we are not making a foundation here, making a canoe. So now it's time to add some fiber. And fiber will make this concrete stiffen up quite a bit. Okay, so you can see I sprinkled some fiber onto the surface of the concrete. I did not measure this out. I just sort of felt by vibes, so don't mix like that. But we're gonna let this mix for a bit, and we'll see how it thickens. So, as you can see, a little bit. It has thickened slightly, but we did put an insane amount of high range in there. So I'm gonna add some more fiber. This would definitely be easier if we had a pan mixer, but I thought the gravity mixer would be a useful demonstration of why I don't like mixing in these. I just got concrete on my finger at you. So I'll give another few sprinkles. Also, when adding fiber, you really want to go pretty slow. If you don't, you can get balls of fiber, and once you start getting balls of fiber, you really can't break them up without just getting your hands in there, and that's just not worth doing. It takes forever. All right. It is stiffer, still pretty liquid. I'm gonna get this out into a container so we can look at it better. All right, last we saw this concrete, it was nothing more than a puddle in a gravity mixer. So now I took that puddle and I added fiber and got a little bit carried away. I meant to show what it should look like. This is what it should not look like. So hopefully we can learn an equal amount from both. But this does give you a good view of different layers inside the concrete. Let me grab something to poke it with. I had a pencil over here, I don't know where it went. Oh, here we are. So, you can see the individual stone from the sand right there.
the larger stone. You can also see some of the smaller stone in there, some breaking apart. The fiber should be very obvious. And then down here, this mixture of water and cement is called the paste. Now, maybe you can hear how thick this stuff is. That's because it is a paste, much like glue. So this was an accident, but I'm gonna call it a happy accident. This shows you a kind of a full segregation of your concrete. Not a good thing, but something that could happen and probably will happen if you spend a lot of time mixing up things that you thought of on an Excel spreadsheet. Not good, as you can tell, you can't make anything out of this. But again, the division of the layers here is useful to look at. So your paste, this is your glue, right? It holds everything together, something strong. Your fibers give you your tensile strength and mean that if you do have a failure in your concrete, it will not be a critical failure. Generally, things will still hold together. You'll just have a crack, which we don't love cracks, but we hate holes even more. Then we can see our aggregate or sand in here, which gives us a lot of the volume and the bulk and quite a bit of strength. Paste by itself is not all that strong, so we do need some aggregate. And paste is also quite heavy. This paste per, I would say, milliliter, as it's a liquid, is probably going to be heavier than these per cubic centimeter, this rock, simply because cement is quite dense. Yeah, that'll be the division and the segregation of concrete. Generally, don't try to make sure your stuff doesn't look like this. This should all be one nice creamy mixture. This is simply put way too much fiber, and then of course way too much high range. When your paste bleeds out like this, or comes out of your mix like this, it's called bleeding. Bleeding is when there's too much high range or too much water, which means your matrix is not stable, which of course an unstable mix is never good. So once this starts happening, it's pretty hard to get it back into a usable mix. Generally, I would just throw it away, especially if you're bleeding to this extent. You're not gonna be able to fix it. It's just, you're gonna have to add more cement, more sand, and at that point, you're not gonna be really testing what you originally set out to. So if you get to this point, toss it, try again. Happens to everyone. Happened to me just now, right?